There is a nature preserve in Raleigh where some rabbits have a reddish-brown coat color. Folktales have long said that these rabbits are a sign of good luck and fortune. These rabbits are rare and not easily found in the forest. You're interested in the inheritance pattern of these rabbits and want to learn more about them, so you begin mating them. To begin the process, we will mate a pure breeding white rabbit and a pure breeding red rabbit. All the rabbits in the progeny will have a white color. We then mate 2 heterozygous rabbits from the previous cross. This generation is peculiar. We have 13 white rabbits and 3 red rabbits. Because the F2 generation has a 13:3 ratio, the inheritance pattern for coat color in rabbits is consistent with dominant and recessive epistasis. Allele A codes for an inhibitor that turns off gene B, which codes for an enzyme that produces the reddish-brown pigment. Reddish-brown pigment is dominant at the B locus, and the inhibitor at the A locus is also dominant. Any rabbits with the uppercase A allele will be white because the inhibitor will be produced. The only way that the rabbits can be colored is if they have the uppercase B allele and are homozygous recessive at the A locus. This is why multiple different genotypes can lead to the same phenotype. These are the possible genotypes from a heterozygous cross. If the inheritance pattern was simple Mendelian, the ratio would be 9:3 to 3:1. We can demonstrate this using a maze for each genotype. Our first case is a genotype with both an uppercase A and uppercase B. We have an uppercase B, which will code for the pigment, but because uppercase A is present, it will inhibit the B allele, so the pigment will not reach the rabbit. Our second case is a genotype with an uppercase A and 2 lowercase b's. The inhibitor is produced, but because the alleles are homozygous recessive at the B locus, no pigment is encoded for. Our third case is a genotype with 2 lowercase a's and an uppercase B. Because the alleles are homozygous recessive at the A locus, no inhibitor is produced, and the pigment reaches the rabbit. Our last case has both alleles homozygous recessive at both loci. No inhibitor is produced, and no pigment is encoded either, so the rabbit is white. The progeny we just discussed was for a dihybrid cross of rabbits, but what happens if we mate individuals that are not heterozygous? We will mate a white rabbit with another red rabbit, but because these rabbits are not pure breeding, the progeny will look different than the last. This is the genotype of the cross. First, we need to make Punnett squares to show the possible genotypes at each locus. Now we can determine the probability of each genotype. Out of 16, we will have a total of 12 white rabbits and 4 red rabbits from this cross. And we know that only one genotype will produce the red phenotype if we go back to the maze. Now we have more good fortune rabbits to introduce back into the forest.